So thank you everyone to share this opportunity for us to introduce the hottest topic in the auto industry, the new energy vehicles. Here, I will give you a brief introduction about the difference between the new energy vehicle as well as the conventional vehicles, and what's the requirement from the raw material suppliers and what we can do from Kingfa side. Because this PPT, to be frank, is a little hardcore. I have to say that if you have any issues, you can interrupt me. We can discuss openly. So this is the gist of the topic. First is the market review of new energy vehicles. In the future, I will use the abbreviation of NEV. Second is the introduction of NEV plastics and composite for the NEV. And then the third one is the further health for the NEV, including the charging pole, charging cables, as well as the battery and the housing. This is the classification of NEV. In fact, new energy vehicles is a large family. Mainly, it's a variant based on the conventional vehicles. Conventional vehicles means we are using petrol or diesel or CNG. But for the energy vehicles, here we say that we are using the electricals and the fuel battery, as well as some solar and other new resource. So as far as now, most of the vehicles already commercialized, but except the pure fuel battery vehicles still now is under investigation. So this is the classification. It's based on the driven type and also based on the types of vehicles, and also based on the battery which they are using, and also based on the final end user applications like commercial vehicles or cargo. And here we can see that in the auto industry, currently mainly we are using the TLB and as well as lithium tarantine. And for us, the most popular in the current scenario, the most popular is HEV and PEV. For the NEV, it has its own characteristics compared with the conventional vehicles. First is the smart. What's the meaning of smart? First is the auto driver pilot assistance system, and auto parking, autopilot. This was proposed by Tesla almost 10 or 20 years back. And the second one is the platformed logic and multitask. And the last one, and also the important one, is the internet thinking. For this one, internet thinking is mainly because of the shared economy. This was very popular in some of the countries, and it contributes a good in the market. This is the global market analysis of NEV. This is the top 20 NEV in 2018. From here, we can see that I can say that almost 80% of the NEV was driven by the battery electrical vehicles, and the rest are the PHEV. In fact, PHEV is also one type of, we can say that is a combination of conventional vehicles as well as BEV. But due to some, policy issues, BEV is more popular. And the global production of NEV in the last year is about 2 million globally. And China contributes almost 50%, USA 16%, and Germany 7%. And here I list one curb weight of the NEV. Here we can say that almost all the NEV compared with the conventional vehicles, the weight increase is a minimum 200 kilos. And at the same time, because in the different countries, the mileage tests are totally different. So I select in the China market, they are following the same method for test the mileage. Here we can see that the last column is the recharge mileage. Here we can see that in the most of the vehicles, it was less than 200. Why is less than 200? Because in the current scenario, due to the battery limitations, and we cannot increase the battery capacity to the level which we want. So in this case, we have to make the balance between the battery capacity as well as for the mileage. As well, at the same time, we have to consider the light increase due to the adoption of battery. And if we compare the same size of the vehicle in the market with the conventional vehicles, we can see that almost 20 to 30% curb weight increase was there. So in this case, how to get this weight reduction by the optimum design and the right material selection is the key focus, is the key factors for the NEV industry. This is the composition of NEV. First is the car, second is the battery, and the last one is the pole. In fact, for most of the guys, the pole and the battery play almost 70% of the success to one NEV. And this is the service provided by us for the NEV. First is the chassis control and the electrical and the electronics. And second is the battery and the powertrains. And the last one is the traditional business, which we are doing is for the interiors and exteriors. Weight reduction for the NEV, we are using several methods, but as far as now, the commercialized vehicle, NEV, is mainly used these three methods. First is the low density, second is the microforming, and the last one is the thin wall. I will give the introduction one by one. And at the same time, this is the application in the interiors for these three technology. Here we can see that it's compared with the traditional vehicles, it including a lot of materials which have the unique requirement. Example, for the bumper. Now they want the density, generally speaking, the density of the bumper is 1.04. Now they want to use 0.9 density with the radar transmission. It gives a very high requirement on the materials selection. And another one is that for the wheel arch, they are using, currently a lot of guys are using plastics. It can reduce another 3 kilos, and the full plastic tailgate, and also LGF dual trim carrier. All this one give some new idea for the conventional vehicles, whether we can consider the same possibility or not in our application. And in the interiors, is mainly they are using the, is almost the conventional, but in some of the case, they also consider extreme condition. Example, for the console, in most of cases, we are using PP with glass fiber or PP with talc. The density, the thickness is nearly about 2.5 millimeter. But in some of the case of the NEV, they use CFRP, which the thickness is only 1.8 millimeter. It gives a lot of flexibility in the design as well as in the stylish. So that's also just now as we discussed. Now the weight reduction in the NEV is almost becomes the key to the success. This is the advantage of the weight reduction. And every 10%, this is the data from the website as well as from the papers. Here we can see that the lightweight is almost the most effective method to increase the mileage, provided that the battery technology did not get too much breakthrough. And by this lightweight, we can increase the energy saving as well as the power improvement and mileage. This is the weight reduction by the thin wall and low density application in the door trim. Here, this is one comparison. And the thickness, we can see that in the most of the NEV, they are using 1.8 mm as well as 2.5 mm different thickness with different flexural modulus. And this one, they can reduce the weight almost nearly about 30% to 40% compared with the conventional design. And another one is the low density and the thin wall technology in the bumper. Here, this is the easy calculation. I think we also, by decrease the thickness, we can save a lot of in the weight. And at the same time, because the weight reduction, we can also get a lot of savings by the cycle time. This is the relation between the cycle time as well as the thickness. Here we can see that if we decrease the thickness from 3 mm to 1.8 mm, we can get almost a 10-second reduction in the cooling only. It means almost nearly about, we can consider about nearly 15% of the cycle time can be saved. Another, because how to say this one, every technology has its own risk. This is a possible risk and the countermeasurement for this thin wall as well as the low density materials such as the pin mark, injection issues, and also tag mark, seam welding lines, and some shining. For such of things, we need to solve from the materials, example like high MFI, high stiffness, as well as high modulus materials, and then from the part design, as well as the mold design. Such of things, we can give the good support to the customer to overcome such of issues. Another one is by the microforming. Microforming is a new technology used in the auto industry. It uses lower injection pressure and lower colliding force and even lower injection temperature also to inject the part with the same quality. And for this one, this is the ICEM of the one microforming part. Here we can see that almost there is no thick mark, and also the forming was quite even. Means the surface is comparable with the unformed materials. This is the part which commercialized in the NEV. One is the IP. Here the weight reduction is almost 20 to 30%. At the same time, they can reduce the cost at 10%. And because the microforming has a very good surface, so it's also applicable for some of the IP, even in the A surface. Another one is for the door trim. This is the one design in Tesla. They are using PCBS as well as in PP. And for this design, they want in the surface, they want to achieve some softness as well as some good aesthetic. Finally, they choose the microforming. And but the main concerns or the main issues in the microforming is also come from forming only. It will give some issues in the aesthetic as well as the gas mark and the welding line. And if the materials selection was not good, then there will be some surface evenness. It means once you notice the surface, it looks like the wave. And then another one is the part performance, because anyhow, microforming, still you cannot fully compete with the unformed materials. It can achieve almost 95 to 97, but still there will be some minor difference will be there. And in this case, we need to see more in the forming structures. It means what's the size of the forming and how it was distributed, whether the forming is well distributed or some sides are bigger, some sides are smaller. This is another one is used by the thermoset. In fact, for thermoset, it contributes a lot in the auto industry. Here, we are mainly talking about the LFT-G and LFT-D and CFRP. CFRP is more popular right now because of the better strength. This is the weight reduction by long glass fiber reinforced materials, and this is the property comparison. Here we can see that long glass fiber PP is comparable with PA with 30% glass fiber, but at the same time, the density is 10% lower, and at the same time, the impact even is much higher. At the same time, fatigue of the long glass fiber is much better than the short glass fiber. This is some comparison at the different test conditions. This is the application in the NEV. Mainly, it used in the door trim, carrier, and the tailgate, and the engine covers. And another one, very important for the long glass fiber, is for the battery cover. I will give you one separate PPT on this battery cover. And this is the technical support which we can provide from our side is for the structure part, because here you are using a lot of CFRP and LFT, which requires some professional advice from our side. First is design on the demand. We can give you the different solutions based on the different distance, at the same time based on the working temperature and the mechanical spec. And we can give you the FEM design with one design, but for the different variant like fuel, PHEV, and EV. We can give you the same design. And compared with the Mento, the weight reduction is about nearly 50%, and the integration can increase almost 100%. And this is the test equipment for the FEM. We can provide such of test in-house, and including the strength, rigid, impact, vibration, and aging. We can give you not only the materials, we can also give you some support on the design, molding, as well as the processing. Another possible applications is for the example for the IP beam, collection beam, and the driven battery rack for this long glass fiber. This was already commercialized in some of the vehicles in the USA as well as in China. And next topic is for the weight reduction by the CFRP. Compared with long glass fiber, CFRP even can achieve another 30% weight reduction by using CFRP. And this is the application for CFRP, like the seat basin, door trim carrier, tailgate. Yes, such of part, some of the part you can use the long glass fiber, and based on your design, you can also use CFRP also. And currently, we got almost more than 20 applications in the electrical vehicles, like the safety part, structure part, and the functional part. In the corner, there is one part called the rear collection beam. In the most cases, they are using steel. Now they have already converted to CFRP and PP with the long glass fiber. The weight reduction is almost nearly 60%. And this is the applications in the motor and the control panel. We can give you different materials, including the battery and the cover and the charging connector and the battery cover plate and the header, as well as battery bracket. Next, we are discussing about some peripheral in the NEV is the car, because just now we discussed in the car which the part is mainly designed by the OEM. Second is which we also design, may be provided by the OEM in the NEV, but it's not there in the traditional vehicles like the pole as well as battery. Because for this one, for the NEV, is mainly restricted to the different countries, the regulation, the safety regulations. I think every guys noticed in the last several months, there was almost record 20 fire accidents in Tesla as well as in some Chinese car makers. So now is how to define the regulation in the electrical vehicles and how to provide the safety to the consumers is become very critical for the NEV. And for this one, some of the tests, because the majority of this spec was designed by the OEM. So first, as I talked, first is the safety, because anyhow, safety is the top concern for us. And example, the safety including the high temperature, low temperature, dropping test, vibration, and chemical resistant, and also electrical safety. And here we must notice there is one new requirement is for the flame retardant. Because in the conventional vehicles, yes, flame retardant requirement was also there, but the spec is less than 100 mm per minute. This is enough for the conventional vehicles, but for the electrical vehicles, in most of the cases, we need flame retardant at V0. Even sometimes it's more critical or more stringent than V0. Later, I will use some examples to give the idea how it works. And also another one is low weight, means no glass fiber or less glass fiber, and then friendly, environment friendly. It can meet rules and easy to recycle. Because recycle, it will become also become a critical issue for us in the future. This is one battery pack. Here, because almost all the battery pack, they are under the seat. So battery pack including several things. One is the shell, and then from the shell, it becomes the modular. From the modular, it becomes the shell. From the shell, then it becomes the unit. In different levels, you have to select the right materials, and some of the materials is almost becomes the only possible solution. And this is one application for IFT. And this was provided by Kingfa for the electrical vehicles. Here you can see that by such of technology, we can use FRPP along with the PP with glass fiber to achieve the good properties as well as good flame retardant. Another one is the injection pack shell. The dimension is almost 1 meter, and the thickness is 3 mm. And by this one, we can easily achieve the flame retardant and as well as the gasoline test. This is what I'm talking about, the gasoline test. Gasoline test means we need to apply the LPG and burning for 10 minutes. After 10 minutes, it should not have any burn out. So this is a test what we are doing in the third parties as well in Kingfa side. This is on the front. This is we are put the LPG for 10 minutes. And after 10 minutes, here you can see that from the back side, it's keep almost the same. From the front side, yes, there is some burning was there, but still there is no burning out. And at the same time, we also test another method, is burning with gasoline for almost 2 and 1/30 seconds. After the fire, after we remove the gasoline, the fire extinguished and there is no penetration. It means if we select such a type of the materials, there will be no burning out of the vehicles like what happened for Tesla last month. And another one is for the blister process. Blister process is mainly used for the anti-dust shell. This is used for the package of the battery. And the size is almost 2 meter by 1 meter. And the thickness sometimes is 2 mm, sometimes is 4 mm. And it was used by the extrusion as well as the blister process. And by such of the materials, we are using the PPS. Why we are using PPS? Because the working temperature sometimes for the battery, for the NEV, especially in the hot area like Chennai, maybe it will come to almost 120 degree or 140 degree. In such of the case, we need the materials which has a very good stiffness as well as humidity resistant. And the most important thing is also for the self-extinguished. It means once you remove the fire, it will extinguish automatically. And the working temperature for this part, it will come to almost 270 degrees. And other materials, because based on the design, you can use different materials, and also based on your cost, you can use different materials for the same battery rack. You can use PPE, you can use PCBS, you can use ABS, and you can use nylon also. It's based on your cost and based on your design, we can give you different materials. And this is the materials comparison for this battery shell. Based on your cost and based on this, you can select the right materials. This is the other function part for the pack rack. Here, you have to use nylon only, because the only issue is that they need thermal conductivity. And recently, we received some RFQ for the same electrical vehicles. It needs very high thermal conductivity, because if the thermal was accumulated in the battery itself, then the temperature will increase drastically. But if this materials was thermal conductivity, then it can emancipate in the thermal in the air, so that the working temperature for this such of battery, it will not go up drastically. Another one is for the electromagnetic shielding rack. This was because for the electrical vehicles, there are a lot of electrical components. So in this case, how to ensure there is no electromagnetic conflicting is become very critical. So we can also give you the different materials, which is with the EMR and the V0, and also the thermal stability. And then this is for the charging. In fact, we made some analysis. The current for the charging now in some of the design is already come to almost 1,000 ampere. 1,000 ampere, it means is even you can use the same power for one plant supply, but all the current should come to by this part only. So we have to select the good thermal stable materials, because during the charging, the temperature may come to almost 170 degrees. At the same time, because in this charging adapter, maybe you will deploy such of the charging adapter outside or in the field. So the blooming is also become very critical. You cannot say that currently you are supplying with red color, but after 1 year it become yellow or it become green. This is not acceptable. And at the same time, we also supply some cables. In fact, for the cables, the current currently we can give is about nearly 1,500 ampere, which can meet Volkswagen One requirement, and also it can work at a very low temperature as well very high temperature. Okay, this is because this is the PPT. If any questions, we can discuss here.